Good morning, everyone. So I think in the last class we were discussing about the TCP and UDP differences. So in that way, I have discussed that TCP is what? TCP is a connection-oriented protocol, right? And that provides a reliable and ordered delivery of data packets between the devices over a network. Right now, how we say that it is a connection-oriented because it is based on the establishing the three-way handshake. So for establishing a connection, it does three-way handshake. For terminating the session or terminating the connection, it does four-way handshake. That's why we say it is a connection oriented. Now, what it does, it ensures that error checking, flow control, and retransmissions of the lost data packets can be done. That guarantees the delivery, data integrity, and consistencies. Correct? Then it establishes what? A connection before transmitting data with the help of what? Handshake process. And what we have discussed that it provides acknowledgement of our received data and packets and manages the packet sequencing. It means that it is going to give you acknowledgement. Acknowledgement is what? It is a confirmation message regarding that yes, I have received the information. Correct? And where do we prefer this TCP? It is suitable for applications where like we can use like a web browsing, email, or file transfer. These are the examples of the transmission control protocols, right? And whatever we have discussed in this TCP, this is not present in the case of where? In the case of UDP. So what happens in the UDP? It is a connectionless protocol that delivers the packets without establishing any connectivity. No handshake process will be there in this UDP. It does not guarantee the delivery or acknowledgement of packets. It means no acknowledgement, no sequence number, no window control, no window size, everything. Then faster transmission due to what? Minimal protocol overhead means it is going to be faster compared to TCP. Why? Because it is not going to spend any time in establishing the connection. That's why we say it is a faster. Suitable for what? Suitable for real-time applications like video streaming, voice over IP, and allows what? Multicast and the broadcast transmissions. We have discussed that generally we prefer TCP in the case of unicast transmissions. Not and in the UDP UDP we prefer multicast for the broadcast transmissions. Now, what is the protocol number of UDP we have discussed? And what is the protocol number of TCP? 6. Okay. So just we will write summarized format of TCP and UDP differences. Then we'll start with the three-way handshake. So TCP is what? First is connection oriented, right?
Yeah.
That video we have not uploaded. It is reliable. Then it requires what? Acknowledgement. It is based on handshake, that is called as a three-way handshake process. Uses handshake. Uses sequence number. Then uses based on window size or wait, maintains flow control. Maintains flow control. Then retransmissions. Retransmission of the lost data packet. Right? Next. Connection oriented, reliable acknowledgement, sequence number, handshake, maintains flow control, retransmissions of the lost data packet. Next, you can write the examples. What are the examples? Email transfer, file transfer, then messages, then web browsing. These are the example, right?
Yeah.
And protocol number, 6. Next, for the UDP. For the UDP, what are the differences? First is connectionless, not reliable, no acknowledgement, no handshake, no sequence number, no flow control, no retransmissions, right? Of the lost data packet. But one more extra point we can add that it is going to be fast. And this one is slow. Examples, live streaming, video calls. These are the examples of the UDP. Protocol number of UDP is what? 70. I'm telling you, I'm not telling that always UDP will be only in the unicasting. Generally, we prefer in the case of unicasting. It can be a broadcast transmission also. Sorry, means we prefer UDP in the broadcasting. It can be other ways also, but generally it is UDP. And this one is TCP is what? Generally unicasting. Clear till here? Understood this? So now we discuss the TCP uses what? Three-way handshake. So we have to discuss how it happens. What are the process of this three-way handshake? TCP port number? Protocol number, I'm telling you, 6. And UDP 7. Now consider here that here we have this is sender and this is receiver. Now what happens that we can consider sender or receiver also or client or server also. Function is same. Now let's say sender is sending to something to the receiver. Before sending actual data transmission, what happens? It will establish a three-way handshake. So what happens in that? First, this sender is going to send one SYN packet. What it sends? It sends a SYN packet, right? Let's say the SYN packet it is going to send is having a number 100. Correct? Now what happens? This particular information will reach the receiver. Will come to know that, okay, this sender is trying to establish a connection with me and he has sent a SYN packet with a sequence number of 100. So what this receiver will do? It will reply, right? So when it is going to reply, what it will send? It will send SYN plus acknowledgement. Now consider that sequence number of this receiver is 200. Sequence number of what? Receiver is a 200. Now what he is sending? Acknowledgement. So when he's sending the acknowledgement of the sender's sequence number, it will add 1 in that and will send 101. Why he is adding 1 in that? One adding of 1 means that he's expecting next data. What it means? One is acknowledgement. Second is that he is going to expect next further data information. That's why it is adding 1 in that. Now, when this particular information will reach to the sender, what the sender will do? Again, it will acknowledge this particular data that it has received. So what it will do? Again, it will send back to the receiver. That, okay, I have received your connectivity, or I have received your sequence number that you also want to have a connectivity with me, right? Same, what it will contain? Final acknowledgement message it is going to contain. That is what 201 and 101 that it has received, right? So once this is done, then what will happen? Three-way handshake process is done. It is completed. After this three-way handshake process, what will happen? Real transmission of the data packet will take place. Now, for example, let's say the sender has sent this SYN packet to the receiver. But when this message reaches to the receiver, receiver is unable to send this acknowledgement. Consider a scenario that sender has sent the SYN packet having a sequence number 100. Receiver is not replying. Acknowledgement, it is not coming from the receiver. What this sender will do? What is written here? Retransmissions. Now the question here comes that, okay, it will retransmit, that is fine. But how many times it will retransmit? N number of times? No, this is not n number of times. See, it depends upon the operating system as well. If you go with the Windows, generally it is going to tell you that first time it will send us in packet and then two times retransmission will take place. It means total three times. Overall, when you search about all these things, so it will tell you that on an average, it is going to have five times retransmissions, but it depends upon the operating system also. So whenever any questions comes that how many retransmission will take place, you can directly say that it depends upon the operating system. First thing, if you count with the examples, then you can start with the Windows, that here it is going to send for the first time. If it is not getting any acknowledgement, then it will retry two more times. It means total three times it will try, right? In general, we can say overall, counting with other operating systems, five retransmissions will take place, correct? And then it is receiving, then it is again sending the final acknowledgement. This is the process. Why it is adding one? It is adding one to signify that I am expecting the next coming informations. That's what. So same thing, it is written here also that it uses three-way handshake process where we have a web browser. So you know that web browser is going to have a certain port numbers, and here we have web servers, let's say a port number 80. So when it is sending data packets, what it happens? Yeah, means a unique port numbers is being assigned, random port numbers. That's why here we have a source port and here we have destination port. Same as SYN, it will reply, SYN and acknowledgement, and finally it will reply with what? Acknowledgement process. Here in this slide, I'm not adding one, but it adds one, right? Now, see, here it is written also what happens with this. SYN is what? SYN, the client sends a synchronized packets to the server, indicating a request to establish a connection and providing an initial sequence number. So it will send a SYN packet where it will contain what? An initial sequence number. Then what we have? SYN and acknowledgement. So server responds with SYN and acknowledgement, synchronized acknowledged packet, acknowledging the client's request and sending its own sequence number. So in this, it will acknowledge the client sequence number and also it will send its own sequence number. And final acknowledgement is what? The client sends an acknowledged packet back to the server, confirming the receipt of the SYN and ACK, thereby completing the handshake process. Right? See? Yes. Next. And next, what it does? It uses four-way handshake to terminate the session. So in this, we have, let's say, PC. Here we have another PC, sender receiver, we can say. So if any device is trying to terminate the session, what it will send? Acknowledgement plus FIN. See, this is based on the flags we'll discuss in the TCP headers that it is going to have certain flags. So when it establishes the connection, for that it will send SYN packet. For termination session, it sends what? Acknowledgement plus FIN packet. When this message will reach to the different client, what it will do, it will respond with the acknowledgement packet. One acknowledgement and another acknowledgement plus its own fin, right? How it was sending its own sin, same as. And then finally, it will send the acknowledgement packet. So whoever is going to initiate the establishing of the connectivity, or whoever is going to initiate the termination of the connectivity, they will only send the final acknowledgement. So here, if this particular PC has initiated to terminate the connectivity, so finally this PC only is sending the final acknowledgement, right? In the case of three-way handshake, if that client device has initiated that particular establishing a connectivity, then finally this device only is sending the final acknowledgement. This is the case. So for establishing a connectivity, three-way handshake, and for terminating, four-way handshake, you have to remember the sequence here. Whatever sequence number that we have written, send, then it will get a reply with both send and acknowledgement and final acknowledgement. Same as in the case of four-way handshake also, you have to remember this particular sequence. Acknowledgement fin, final acknowledgement, then again acknowledgement fin, and then final acknowledgement from the PC. Hmm. So if this particular device, let's say this is a PC1, this is a PC2, they both were communicating. Now they have to terminate the session. So directly they are not going to terminate the session. They will have a connectivity in that. So what happens that it is going to send acknowledgement plus fin. Acknowledgement means what? Acknowledgement, let's say the last information that it has received from the sender. It's considered this is sender. For example, all the process has been done. He has received the last information. So when he's receiving the last information, what he will say, okay, I have received the information. Now I want to end the session. This is your final information that you have sent it to me. I have received. But furthermore, I don't want to receive anything. I want to end the connectivity. Because see, you whatever you are receiving, you have to acknowledge for that. Once you have acknowledged, then what you are telling, now I have received, now I want to end. Delivered, then what it will do, okay, I got your response that you have received. Now you want to acknowledge, means end. So I have received your information that you want to end. Same thing, he will tell you, okay, I am also willing to end now. Acknowledgement plus its own fin number, right? And same when it will receive, okay, I got your response, then finally he will sending, let's end the session here. That's why the first acknowledgement here in the case is signifying that this is the final information that has been delivered from you and I have received that. Now I am initiating my end process. I want to end the session, right? And for that, it sends the fin. And final, it will send acknowledgement confirming the message it has received from him. And again, sending his own acknowledgement plus fin. And final acknowledgement will come from the particular receiver sites, right? Even if you remember the sequence number, the sequence, who is sending what, it is enough. Same thing if you will see the book of CCNA Volume 1, Volume 2, you will find the same process it is explaining. Correct, no? Hmm. Where? This one? This one? Yeah. So see, for example, that it has told that this is the acknowledgement for what? This one, termination messages. And this is telling you that, okay, I have received your information for termination, and this is my own FIN number. Let me show you in the book first. Okay, so here it is just defining what is connection oriented and connectionless. It is not explaining all the processes, right? So what it says for this, a connection oriented protocol is what that requires an exchange of messages before data transfer begins, so that it has required a pre-established connectivity between the two endpoints. Connectionless, a protocol that does not require any exchange of messages and does not require a pre-established correlation between the two endpoints that we know. Yes. So TCP connection termination, this 4-bit termination sequence is a straightforward and uses additional flag that is called as a fin bits. Fin is what? Finished. So one interesting note, before the devices on the right side sends the third TCP segments in a sequence number, it notifies the application that connection is coming down, and it then waits on an acknowledgement from the application before sending the third segment in the figure. And just in the case of application, okay, PC1 on the right side second send the flow in the figure acknowledging that the PC wants to take down the connections, right? The same thing, that it is telling you that it has acknowledged the final information. For that final information that it has received, it will send a confirmation for that, and it will initiate a finishing that I want to terminate the session. Next, it will come to know, okay, I have received your request to terminate. And second, it will send that, okay, I have received your connectivity for termination. Second thing, even you have received my final acknowledgement. And third thing, even I want to terminate the session according to your request. And finally, it will come to know that, okay, he is also willing to terminate the session. That's why finally he's ending the session, right? This is the process, correct? Acknowledgement means what? Acknowledgement is always the confirmation message from the senders or any receivers. If it has sent something, it has to acknowledge. That's why it is a connection oriented and reliable connectivity. Without acknowledgement, it will not send anything, right? So these are the differences. One is connection oriented, connectionless, acknowledgement, no acknowledgement, handshake, no handshake, slow, fast, reliable, unreliable, sequence number, no sequence number, flow control, no flow control. Correct? So there are various application layer protocols. When we will discuss about the application layer protocols, all the protocols will be either using TCP or it is going to use UDP. All the protocols. So if you will find here application layer protocols, we have Telnet, SSH, then TFTP, FTP, SNMP, STTP, HTTP, DSCP, next NTP, same as we have DNS, domain name server, domain name system. So we'll discuss all these application layer protocols one by one, but not now, right? When we will start with the practical, there only I will start with the Telnet and SSH so that I can do the theory also and I can show you the practical of the Telnet and SSH both. Same as when we will start with the DSCP, we'll discuss DSCP and we'll do the practical for the DSCP. Same as for DSCP delay agents, DSCP snooping, DSCP spoofing like that. And then we will do with the DNS like that we'll discuss, right? So now first we will discuss with the headers. So I think I have told you to write certain information regarding the headers in the last class. Have you written that? What? So if you have written, tell me first, what is the size of the TCP header? Wrong. The size of the TCP header is 20 bytes to 60 bytes, right? So what are the information it contains? See, first thing, what do you mean by this term header? Header is a set of information that enables the transmission of the data from one location or from one device to other based on certain information like source port and destination port number. Then any other informations like sequence number. These are the examples I'm writing, but all the information we can get it in the header. So like that, we have TCP header, UDP header, Ethernet header, IPv4 header, IPv6 header, correct? So like how we have tickets, like when you travel, where you are traveling from one place to another place, railway, maybe you have booked any flight ticket or railway ticket. So in that, all the information is present, no? From where to where you are going, what is a flight number, train number, seat number, everything. So all that information enables you to travel from one location to the another location. Same as here also, it is the same thing. It enables the devices to send traffic from one location to the another location. Correct? So first we'll discuss with the TCP header. So TCP header is going to have the information regarding the source port number, source port, destination port, sequence number, acknowledgement number, data offset, reserved, black bits, checksum, window, and urgent. These are the header information in the TCP header. Now we'll discuss what is this source port. See, what is the size of the source port? 16 bits. 16 bits means what? 2 power 16 variations are possible there. That many variations are possible for the numbers. So source port is like what? It is like a similar to the sender's address, and it identifies the application or the processes that initiated the data transfers. So the sender will send a data with its own sequence number that is called as a source port number. Right? We have discussed that random port number will be assigned for each data, and that is from where ephemeral port numbers. So unique port numbers will be assigned from the sender side. Same as we have a destination port number, same size, 16 bits, and it is like what? It is like a receiver's address. What it does, it identifies the application or processing that is expecting the data that is going to receive. So example we have discussed, let's say a sender port number we have 65,000. The destination port number will be what? Let's say you're using HTTPS. So that destination port number will be what? 443. If we're using HTTP, then it is going to be called as what? 80, right? No. Now, you know that, okay, we have very large data. So that large data has to be divided into small segments, correct? No? Large data we have that has been divided into small segments, and each segment is going to get what? A sequence number. Now, what is the advantage of a sequence number? See, first thing, sequence number is having 32 bit size. It means 2 power 32 variations are possible there, right? So sequence number, what it will do? It is a unique number assigned to each packet. It will help you for tracking. Tracking means identifying what is the location of that particular segmented data. Next, what it does, it ensures that they arrive in the correct order. Like one sequence is being followed. Let's say this is one sequence is we are maintaining that 1, 2, 3, 4, 5, 6, 7, 8 like that. So based on that sequence number, what will happen? The transmission will take place so that it cannot be mismatched. That's why we use this particular sequence number. What is the size for that? 32 bits. Same as we will be having what? Acknowledgement number. Same is size is what? 32 bits. This is what? A confirmation message from the receiver to the sender acknowledging that which packet has been received successfully. So if the packet has been received successfully, what it will do? Final acknowledgement will be delivered from where? From the letter receiver to the sender that yes, I have received your information. With what? A acknowledgement number. Whatever is happening here, it is based on the numbers, right? That's why it is telling you that this is the size of that particular sequence number. This is the size of what? The acknowledgement number. Now, why it is going to have this many sizes, these many variations? Because it is not that always it is going to send only one data. No? It can send multiple data. So all individual data has to get what? Unique sequence numbers, right? That's why it is going to have these many variations so that each segmented data can get what? Sequence numbers, then acknowledgement number like that. So let's say, for example, you have received any particular data. So you have to acknowledge that particular data only. No, you cannot send any acknowledgement for any other received data, right? So it should match. Okay, this is one I am sending. So he's replying for the one only. That's why they both are having a equal particular variation, 32 bits and 32 bits. Correct? Hmm. Hmm? When sender is sending something data, so first it has to acknowledge no. When it is going to acknowledge, it will send its own sequence number. Where if sender is something in that time, how acknowledgement will come? Until and unless it has received, then only it is going to acknowledge no. Correct? Next is what? Data offset. What is the size of this? Indicates the size of the TCP header in 32-bit words, helping with efficient processing. Means it is what it is going to do. It will contain the information about the TCP header size, whatever the actual information that we are transmitting. What is the size of the particular TCP header that it is going to inform you? Means data plus the header size. See, you have to understand here two things. Let me write that. One term is there that is called as an MTU. What is MTU? Maximum transmission unit. MTU, maximum transmission unit. It is a value that includes both size of TCP header and data size. MTU is what? Maximum transmission unit. It includes, it is a value that includes both the size of TCP header also and the size of the data also. So maximum MTU value in Ethernet is 1500 bytes. Ethernet is what? Ethernet is a technology that is used to connect multiple devices in the LAN environment. Using what? Using Ethernet cables. That can be gigabit Ethernet, fast Ethernet, normal Ethernet cables, right? So it depends what type of cable connectivity we have taken. But Ethernet is what? It is a technology in which multiple devices in the LAN environment has been connected. So in that maximum transmission unit is what? 1500 bytes. If the size of the data is beyond 1500 bytes, what will happen? Segmentation will take place. Let's say you are sending 6000. So 6000 size of the data will not be delivered. What will happen? That will be divided in the multiple of 1500, 1500, 1500, like that. So four individual packets will be delivered if you have 6000. That's why it says what? Maximum at one time I can send 1500 only. Less than that I can send, no problem. But more than that, what is required? Segmentation is required. Correct? This is maximum transmission. One is MSS, maximum segment size. This is very important. I'm discussing. From here only, questions can be asked to confuse you, right? What is maximum segment size? It is a value excluding header information. It means it contains the information regarding data size. Correct? What is the MSS value? 4060 bytes. Right? One more thing is there. That is called as a payload. What is a payload? Payload means what? Size of actual data is called as a payload. So now we have written here MSS. MSS, it means we can say that this is the maximum segment size. So this is the maximum payload. If you write in general idea, what is payload? Size of the data. In MSS, what is written? Only size of the data. And what it is? Maximum. So what can be the minimum? What is the minimum payload size? Minimum payload 46 bytes. 46 bytes is the minimum payload. In the TCP, most important part is what? Headers only. Okay. I'm not telling that they will ask you that, okay, tell me all the fields. These are what? Whatever we are discussing now, it is called as a fields. Let's say source port, destination port, sequence node. These are the fields, right? So there will be no direct question that tell me what is the source port and destination port, what is the size of that. Random questions will be, tell me the differences between urgent flag and urgent pointers. Okay, we'll come to that part. Correct. Tell me the differences between push flag, reserve flag, like that. Fine. Same as questions can be, what is MTU, what is MSS, what is payload. Correct. See here what it says. This is we are talking about the Ethernet header. This is Ethernet header, right? So in this, it says that here we have certain information like preamble. SFD is what? Start frame delimiter. Then destination address, source address. Type means what? Type means type. In the type, it will contain the information regarding which type of IP version you have used, whether IP version 4 or IP version 6. Next is data. See, what is the range of the data? 46 to 15. 46 is what I told you minimum. 15 is what? Maximum. And this is what padding. See, it says that if the data size is less than 46 byte, what it requires? Padding is required. Okay. Padding is required when the data size is less than 46 bytes. And the last one is what? FCS, that is called as a frame check sequence. So now, see, wherever the information that is regarding preamble, SFD, destination, source, type, this is called as a header. And this is called as what? Trailer. So you can say that trailer is the last information coming in the header. That is called as a trailer. And it can contain what information? FCS, that is called as a frame check sequence. Right? So what is the size of the preamble? 7 bytes. It is telling you preamble is 7 bytes. What is the meaning of this preamble? Synchronization. Synchronization means what? 010101 like that. Synchronizing the data means it is trying to establish the, like, before sending, it will synchronize that I am going to start this. Like how you are before riding the bike, what do? You start, no? Like that it is doing synchronization. Same as we have what? Start frame delimiter. This is the size of it. The size is what? 1 bytes. Now what it says? It says that this is the end of the preamble. Preamble is ended here. Now this is the final step. This is the start frame delimiter is the final step. After that, after this, actual transmission will take place. Right? That's why it says the signifies the next byte begins the destination MAC address. Means it marks that this is the end of the preamble. Now we'll start with the next information that is called as a MAC address information. Right? So between the MAC and between the preamble, what is there? Start frame delimiter. That marks the end of the preamble. It means synchronization has been done. Or it will give a warning also. If synchronization has not been done, do it fast because next information you will get the source MAC address or destination MAC addresses where you have to send the information. That's why here we have what? Destination MAC address. What is the size for that? 6 bytes. That identifies the recipient of the frame who is going to receive this information. Destination where it has to be sent. Then what we have? Source MAC address. It means it identifies the sender's addresses. And as I told you that here we have what type. Type means what? It can contain the information regarding what? Which type of IP version is being used. Version 4 or version 6. Next, see data and padding. So 46 to 1500 bytes. See whole data from the higher layer, typically layer 3 PDU, usually an IPv4 or IPv6. The senders adds padding to meet the minimum length requirement for this field that is called as a 46 bytes. This is the minimum size of the payload. Payload is what? Size of the actual data. That is 46 bytes, minimum payload. And frame check sequence is what? That is going to a method for receiving the NIC, network interface card, to determine whether the frame is experiencing any transmission error or not. So error-free transmission will take place based on what? FCS, that is called as the frame check sequences. So whenever the discussion is based on the Ethernet header, in the Ethernet header, this preamble and SFD is not counted. What is the size of the Ethernet header? 14 bytes. So when you will say 14 bytes, in that, what is not there? Preamble and SFD is not there. It does not consider as a part of the Ethernet header. It is a starting part that is responsible for what? Synchronizations, not actual part of the Ethernet headers. Right? No? Next is what? Reserved. This is reserved is set for zeros. And this could be used for the future use. If any other extra information has to be added, that is present in the reserved bits, 6 bits. Now here, this is the important size, flags. We are going to have different flags in the TCP headers. Total, how many flags? 6 flag, 6 bits. It means each flag will be of 1 bits. So it enables the TCP functions like establishing or ending a connections. Now see, what are the flags we have in this? First is what? Urgent. Urgent flag. See, now you tell me, here in the flag also we have one urgent, and in the TCP header field also we have one urgent. But they both are different. Urgent. This is called as an urgent pointer. And this is called as what? Urgent flag. So we will write the differences first. Urgent flag. First thing, urgent flag. It determines whether the urgent data is present or not. Means, who will give you the information whether urgent data is present or not? Urgent flag. How? If urgent data is present, the flag will be 1. If it is not present, the flag will be 0. Right? So if it is present or not, who will so give you the information? Urgent flag. Now, what urgent pointer will give? It will give you that if that urgent data is present also, what is the size of the urgent data will be given by what? Urgent. So it gives the information, it gives the information regarding the size of the urgent data that is present. Right? Urgent flag means it will give you the information whether this is present or not. If present, then what is the size of that will be given by the urgent pointer. Correct? See, so we have one urgent indicates that data should be prioritized, marking with 1 or 0. Next is what? Acknowledgement, that is confirmation received of a data. See, that is this acknowledgement is for what? For handshake process. This will be used for handshake process, whether it is 3-way handshake or 4-way handshake, right? That acknowledgement is what? For the data. That yes, I have received the information. Actual transmission that will take place. Next is what? Push flag. Push flag tells the receiver to pass the data to the application immediately. We have to remember this part of definition. Okay. What it does, it tells the receiver to pass the data to the application immediately. Now, question for you, whether it tells to transfer all the data or any part of the data. It depends also. It depends, right? Some it can be all or it can be any particular. Depends, right? What it does, who will send? Sender. Remember that who will send everything. In push flag, sender will tell the receiver to pass the data to the application so that the data waiting in the buffer can be transmitted fastly. Right now? See, I told you, urgent is forward. Understand the differences. Push is to clear the buffer. Urgent is to mark whether it is present or not. They both are flags only. But this flag is used for what? To push. This one is used for what? To present, to signify whether urgent data is present or not. Now tell me, what can be the example of urgent? No. For example, let's say I am downloading something. You're downloading anything. So whenever you're downloading, one process is established. Okay, one by one, everything will be downloaded. Now in the middle only, you cancel it. So when you cancel it, what happens? It is that all the things will be first downloaded and then it will be cancelled. It happens like that, or in the middle only, it is going to be cancelled. Middle only, no. It means who travels fast. That process that is being followed for downloading, or this command that we have given now, cancel it. So that cancel command processes faster. No, it means this is what this is a urgent message. That my now what happens that client is not willing to receive this information. He is trying to end that. So this is fastly it is going right. So whenever the information is traveling, in that it is being determined. Okay, this particular information it is going to cross. It is going to be urgent. Urgent messages these are right. So this can be one example. Whenever we are transmitting it, whenever we are sending it, whenever we are downloading it, and whenever we cancel that process, this is an example of urgent pointer. Correct? So who will, whenever you are clicking that part, so urgent flag will be one that yes, urgent data is present in that. It has to be traveled fastly. What is the size of that? Urgent pointer will say. Correct? Got the idea? What is push and what is urgent? Push will be used when you have lots of data betting in the buffer and has to be cleared fastly. So next, in that scenario, sender is telling the receiver to pass the data to the application immediately so that I can send the further more data that is waiting in the queue. Right? Clear till here? Next is what? Reset. So reset is a TCP connection used when there is an error or unwanted connection has been established there. Reset. Retest, reset, retransmissions. Or you can say, let's say a connection has been made, but that particular connection is not maintained. So what is required here? Reset, retransmission, retry you will do. Whenever your device is not working, what you do? Again, restart it. Reset is, that's why we have reset a TCP connection used when there is an error or unwanted connection between the client and the server. Correct? Synchronize, we have discussed that this is what it contains a send packet that is having a sequence number used to initiate a TCP connections and synchronize the sequence number. And this fin will be used for what? Finish. That is closes the TCP connections and it says no more data will be sent. Clear till here? Hmm. Yes. And when you do the three-way handshake, in that again certain more information is being transmitted, like window size information. In the handshake process only, window size information will be delivered. That this is my size, I have to receive this much only. Do not send beyond this limit. Otherwise, what will happen? Data loss will start, right? So when it sends, it contains other essential information also. This you can understand when you will capture the packet. And for capturing, you have to use EVNG, and EVNG is not in the CCNA. Okay, clear till here? So what is the size of TCP header? 20 to 60 bytes, having a range. So in this, what are the important points? MTU, MSS, payload, urgent flag, urgent pointer, push, reset, all the flags. Remember all the flags. No need to remember all the sizes. Just you have to know about the flags and the fields information.
So our payload and segment size both same.
Payload is minimum.
Hmm.
Segment size is the maximum that we have discussed. Clear? Yes, online students, any doubt, any questions still here?
Sir, I think the difference between payload and
What? Any questions, any doubt till here? Okay. See, I told you payload is what? Payload is the actual size of the data, right? So actual size of data is what? 46 byte. That is the minimum payload. MSS is what? Maximum segment size, maximum size of information that is being transmitted, excluding the TCP header size. See, in this, if you will see here, that M2 is what? Total TCP plus header plus data size. MS is what? Maximum data size only. That's all. It will not contain the header information. See, what are the benefits? Why do we do this? Why do we use these headers? So based on these headers, everything is addressed correctly. Source port, destination port is being there. So from where we have to send till where we have to send, all the information will be there. That's why it is called as a addressed correctly. Next is what? Ordered correctly. How? Based on the sequence number. Controlled correctly based on the again sequence numbers and the flow control that it is going to maintain. Sized correctly, verified correctly with the help of what? Error checks, frame check sequences. Checking error can be done. Correct? Next. This is what? Window size. It specifies how much data the receivers can handle at one, preventing the network overload. Checksum is what? A calculated value will be used for error detection, ensuring the data has not been corrupted during transmissions. An urgent pointer marks the end of the urgent data with packet, prioritizing its delivery. Correct? And see, whatever the information that we have seen in the TCP header, all that information will be missing in the UDP header. See, in the UDP header, what is present? Source port, destination port, length means what? Data size, and checksum. That's all. What is the size of UDP header? 8 bytes. Note down all these points. Size of UDP header? 8 bytes. 20 to 60. Eight bytes. Very less number of information is present in the UDP header. Correct? No questions? Okay. As I told you, application layer protocol we'll discuss one by one when we'll start the lab. See, this is written about the MAC address. So MAC address is 6 byte long, or we can say 48-bit long. It means size of the MAC address is what? 48 bits. So it can be called as what? It has various names like Ethernet address, or we can say Ethernet address, hardware address, burned in address. Burned in address is also named physical address, universal address, or the MAC address. Now, who gives this? See, as I told that it is going to be a 48 bits. So first 24 bit is based on OUI, that is called as a organization unique identifier. Okay. And last 24 bit is the vendor assigned, means vendor will be assigning this. This is based on what? OUI, organization unique identifier, IEEE standard. And this is what vendor assigned. First 24 bits, last 24 bits. So for example, if you will take any MAC address, this is MAC address of device.
Yeah.
Now see how it is written. That this is total is of 48 bits, right? So this one is will be 4 bit plus 4 bit. It means 8. 8 into 6 total 48. So the range is going to be 2 to the power 3, 2 to the power 2, and 2 to the power 1, and 2 to the power 0. So 8, 4,
2,
2,
1.
and 1, right? Now, if you have to write in this, how we write 1? 0,
0,
0,
0.
0, 1. Next, let us write 12. 8,
1, 1, 1, 0.
okay? Now, you tell me why we have here D, C, B like that? Hexadecimal. Okay, it means we can say that this MAC address uses hexadecimal format. So what is this hexadecimal format? Why do we use this? My question is, why do we use this? Okay, let's say you want to write 112. What you have written? 112. Now you know that how you have to write these numbers in the multiple of 4 bit and 4 bit. It means total 8 bits. So for writing this, are you going to use 1, 1, 2 separately? No. It should be in the combination of two numbers. See, here I have 112. Total how many numbers? 3. But I have to write into what form? Combination of 2. How will you make that? I will tell you. I will make it as 1 and 12. Okay, you are telling I will make it 1 and 12. Fine. Then you will write 1 to the bit form. Write that. 0, 0, 0, 1. Next, you will tell I will write 12 into the bit form. 1, 1, 0, 0. Right? Done. Now, I will tell why not I can write 112 in this format, 11 and 2. Understanding? Now, I will write 11 into the bit form, 8 plus 2, 10 plus 1, 11. It means 1, 0, 1, 1. And then I will write what? 2 into the bit form. That is what? 0, 0, 1, 0. Now you tell me to write that one single number, we have two different methods or not. So confusion is there or not? Confusion is there. If you are writing 112 into the multiple of two numbers, so one you have taken 1 and one you have taken as a 12. So you will write like this. Then someone can tell, okay, no, I will write it as a 11 and 2. They both are correct, no? They both are correct, but confusion is there. So what we can do that if you want to write this as a 1 and 12, then better to write A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. One minute. Yes, right? So it means here, if you see A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So it means that if I have to write 1, 1, 2 into this format, 1 and 12, what I will write? 1 and C. Instead of writing 1 and 12, what I will give you? 1 and C. I want that you have to write 1, 1, 2 into this format, 1 and C. It means 1 and 2. Here, if I want that you have to write into the 11 and 2 format, it means what is 11? B. And what is 2? 2. Now they both are unique. Now they both are unique. Now you can decide that, okay, this 112 can be written in this format or it can be written in this format. For that, you will get the value only like this 1C or B12. If you have got value as 1 and C, it means you have to write 1 into the bit form and 12 into the bit form. If you have got B and 2, it means you have to write 11 into the bit form and 2 into the bit form. Same number, but two different particulars alphabets. This is called as what? Hexadecimal format. Huh? Where? Huh? If we have here D and 4, it means this is 13 and 4. So first you have to write 13 into the bit form and then 4 into the bit form. Clear? Online students, take the screenshot for this and you all write down this. Right? So this is how we can write 1 into the bit form, D into the bit form, same as C and B, 2, 9, and 4, 5. Total when you will write, you will get 48 bits. This is important to understand because IPv6 is based on the MAC addresses. Till here it is clear. Next, we will start with the cables. and see what it is written here. That when a switch receives a frame, it records the source MAC address and the port that it arrived on. We have discussed this part. Storing this information is called as what? MAC address table. If the switch does not receive any frame from the MAC address with a specified aging time, what it does, it assumes that that device is no longer active and removes the entry from the table. It means, let's say for the first time, it maintained that F01, with F01, one device is connected, that device is having this particular MAC address. After some time, that device is not communicating what it has to do. It will remove that particular MAC address entry from that particular MAC address table. So till how much time it will have that information, that is called as a 300 seconds or called as a 5 minutes. This is called as what? MAC address aging time. MAC address aging time is what? 300 seconds, or we can call it as a 5 minutes. So the MAC address table uses what? It is also called as a CAM table. That is, we can say content, addresses, memory. Now, can we change this particular default timing? The timing that we have is 5 minutes maximum. It will wait for the 5 minutes or 300 seconds. If it is unable to receive any information from that particular port, what it will do? It will remove that information, MAC address information. So can we change this timing? Yes, we can change, and this is the command for that. What is the command? MAC address table, aging time. Then you will write in time in seconds. For that, you have to write a question marks. Then it will be visible. This is a range of the seconds. In that, you can change. And at last, we have to write here VLAN. So when I will start the practical, maybe by tomorrow only, so I will show you how to change this. Okay, in a switch. Clear? Now we'll discuss about the cables. See, in this, we will be discussing about the twisted pair cables. We also had coaxial cables, but that is very old cables. Now we prefer the twisted pair cables. So in this, what happens? Twisted pair cables are common type of cabling used in networking and telecommunications. See, as the name only suggests, that these cables consists of the pairs of wire that is twisted around each other. So what is the benefit of this twisted pair? See, this twisted pairs will reduce the electromagnetic interferences. You know that same cables can be used for sending also or receiving also. So further, more traffic will be there, more interferences will be there. To reduce that interferences, what is there? Twisted around each other. How it is twisted? See, this one. Are you seeing here? We have a cable in that all the wires are twisted around each other. To reduce what? To reduce electromagnetic interferences. In the twisted pair cables, we have two types. One is called as what? Unshielded. And one is called as what? Shielded. If you will see here in the shielded, we have extra foil, extra covering over there. And in this, we don't have any extra covering. It means now, if you will compare both, directly you can say that as it is going to have an extra covering, it means compared to UTP, STP will be little costly. First thing. Second thing is what? As it is going to have extra covering, it means it is going to provide more precaution from the electromagnetic interferences compared to what we have in the UTP. But STP will be preferred in a very high traffic conditions or in the home environment, in the office environment. What is being preferred? UTP. Because we have less traffic, that's why we can go with the UTP also. So there are differences. What are the differences between them that we have to discuss? and see it is written here also, that each wires is twisted together to reduce the electromagnetic interferences from the external sources and from the adjacent pairs. Correct? Because whenever transmission is taking place, a magnetic effect will be created there, right? And if it is being created, so what happens if everyone is creating, then what will happen? More interferences will be there, and we have to reduce that interferences. So first is what? Shielded twisted pair. So STP have an additional layers of shielding that is called as a metal foil or braided mesh around the twisted pairs. So that shielding provides what? Extra protection against electromagnetic interferences. This is typically more expensive than the UTP due to the extra materials and complexity in manufacturing. Why it is going to be more costly, more expensive? Because of extra materials that it has. Now, whether it is suited for what environment with a lot of electrical noises or interferences. It means what? Where we have more numbers of interferences, more traffic, there we prefer what? STP. So it is going to be heavier and less flexible and can make installation more challenging compared to what we have the UTP. See, whatever the cables are you seeing there in the rack, yellow color, visible. Yeah. These are the examples of the cables of twisted pair only. And it depends in that what type of cable we'll be using based on the color coding. We'll come to that part. And this is what UTP is what? Unshielded twisted pair cables that do not have any additional shielding around the twisted pairs. And the only protection is the twisting around itself. That is only the protection, no any extra covering over there. So it is going to be generally cheaper than the STP and more cost effective for many applications, lighter in the weight, more flexible and easier to handle. Ideal for the environment with the minimal interferences such as residential and the most office settings, right? So now directly we cannot use this twisted pair cables. We have to change that part. So when you are having any twisted pair cables, you have to use color coding. Based on that color coding, you will change that cable style. See here. Are you seeing we have certain cables, color coded colors here? Mhm. So what is required? You have to remove this twisted part. You have to open that, make it straight. After making it straight, you have to arrange this in a color format, both sides, because you know that a cable will be having two parts. Let's say one cable is there, correct? No. So it is going to have two part. One part this one part, two side. This side will be connected to one device. This side will be connected to the one other device. So now this side will be certain color coding because here we have to make it straight. You will arrange according to the colors. This side also certain color codings. You have to make it straight and have to arrange it and according to the color. Now what happens if both the side, if colors are matching, then that type of cable is called as what? The straight through cables, right? Now, okay. First, what you did, you have make every wires you have to make it straight, and you have to insert this into the RJ45. What is RJ45? A connector. Okay. See, this is how the RJ45 looks. This are you seeing here? Yeah. RJ45. This is a RJ45 connector, the transparent one. Now, see in this, if the color coding is like this, means what is the color coding? Visible, no? White, orange, yeah. Orange, white, green, blue, white, blue, green, white, brown, and brown. See this side. And this side also color coding is what? Same only. It means that if you will try, if you will have taken the cable, if you will try connecting like this, and when you will match the color coding, it is what is the example for that? Straight through cables. And straight through cables are used for what? Straight-through cables are a specific types of twisted pair cables used primarily in networking to connect different devices. This is important to understand. If color coding is matching, color is same, device is different. It means router to switch, switch to PCs, what you will use? Straight-through cables, right? So in this, what happens? Color coding is matching. This is a color coding. Both sides we have white, orange, white, orange, 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 white, green, blue, blue, white, blue, green, white, brown, and brown. Correct? Next is what? Crossover cables. And then see in this, color coding is not matching. Here what we have? White, orange. This side, white, green. This side, orange. This side, green. White, green, white, brown. Blue, blue. White, blue. Then green, orange, white, brown, and brown. What is here mismatching? Orange, orange and bright orange, right? So if color coding is not same, it means that crossover cables are another type of cable that is used to connect similar devices. It means router to router, switch to switch. Then you will use what? Crossover cables. Straight through is for what? Different. Crossover is for what? Similar devices. And this is the color coding. Sometime when you will go for the interview, they may give you one cable, twisted pair cables, one RJ45. They may tell you that make it straight through or crossover. You have to make it.
We have to remember the sequence.
Yes, you have to remember the sequence of the colors. Okay. So once it is done, then you have to put it in the RJ45. Then there is one tool that is called the crimping tool. You have to insert in that, then you have to crimp it. Will be done. Right? So now whatever the cables that you will see, that is not man-based, that is machine-based. That's why it is very perfect. But when you will do from your side, it is not going to be very perfect, right? And this is the color coding for the crossover. White, orange, green, white, orange, blue, white, blue, green, orange, white, brown, and brown. What you have to remember? Basic thing, straight through, different devices. Sorry, straight through, different devices. Crossover, same devices. Next is what? Console cables. See, console cable is also called as a configuration cables. Means this will be used for what? Configuration purpose. See, this type of port we don't have in the laptops now, right? So this side you will have to get one more connector for Ethernet types or C types, we can say any other types. That connector you will put into the laptop, and this side you will put into the routers or on the switches where you are doing the configurations. Let's say this one side you have taken one more connector. This is what? This is a CDL port, right? So we have taken one connector here. That connector is in the laptop. This side you have put into the router. Done the configuration, remove it, put into the next device. Do the configuration, remove this again like that. That's why we call it as a console cables or primarily can be configured cable. So console cables, also known as what? Rollover cables, are a specialized cables used for primarily for configuring and managing the networking devices like routers and the switches. Right? See, till now what we have discussed, it is like an Ethernet cables, right? Like connecting in my own LAN environment, routers, then switches, then again PCs, some other routers, switches, PCs, right? But how do we get net connectivity? Are we going to get this connectivity with this Ethernet cables? No. What we use is for that? Fiber optic cables. Like you know that we are going to have net connectivity. You communicate with any person located in different part of the country, maybe in US, maybe in the Europe. How you have to communicate with them in with the internet, and how this internet traffic flows. Fiber optic cables, right? So like in Ethernet, we have discussed that we have certain Ethernet cables, fast Ethernet, gigabit Ethernet, right? So fast like Ethernet cables will provide you the speed of what 10 Mbps, faster than 100 Mbps, gigabit 1000 Mbps, right? So that is not sufficient. What we use fiber optic cables for long distance transmissions of the signal and traffic, correct? So fiber optic cables uses glass as the medium through which the light passes, varying the light over time to encode zeros and one. Now, what is the speed of light? 3 into 10 to the power 8 meter per second. This is the speed of the light. It means very fast it is. That's why what it uses, it uses signals to be transmitted in what form? Light form. So fiber optic uses fiber glasses, right? Which allows a manufacturer to spin through a thin, long fiber glasses. This is called as a core, where the glass is present. So the fiber optic cables holds the fiber in the middle of the cables, allowing the light to pass through the glasses. Very high speed, long distance transmission without data loss. And why it is going to have a outer jackets? Then what we have? A strengthener. Then what we have? Buffer. Then what we have? Cladding. And at last, what we have? Core. These many extra layering we have. Why? Because this fiber optic cables has to be put under the ocean. Where it is being put? Land plus ocean under the sea. At where? Seabed, bed of the sea, last portion, right? So if it is led there, then there can be a very high chances of disruptions. That's why it is provided with the extra layering over that. Now, recently we have a news for that. Have you heard that news that under the Red Sea, this fiber optic cable has been disrupted. It has been cut. So the net traffic in the around the Asia, around the Middle East and Europe has been affected. Do you know this news? Recently only, just 3 days back, under the Red Sea. Red Sea is surrounded by what? Saudi Arab, Yemen, Sudan, these countries. And that is providing a strategic location for cabling system for transmitting to the Europe, Middle East, and the Asia. That has been disrupted. Why? It has been cut. How? What could be the chances? The chances are ships anchor is there, no? That is the chances. That is the cause of that particular cut in the fiber optic cables. If this will happen, what will happen? Total disruptions of the traffic, internet traffic, right? These are the reasons. So that's why it has provided what? So many extra layering so that it cannot affect the transmission of the traffic, right? So what it does, it refers to the fiber optic cables in which fiber optic cables made of thin strands of glasses to transmit data as a light. It offers several advantages: high speed data transfers, then long distance retransmissions without data loss. It is secure, it is reliable, high bandwidth, low latency. What do you mean by term bandwidth? Maximum speed. Bandwidth is what? What is throughput? Actual speed. Maximum is different. Actual is, let's say, maximum speed of your car is 240. Are you driving at 240? What do you are driving? Let's say 80. So that is what actual throughput, right? Latency is what? The delay in the transmissions. So fiber optic cables are widely used in the internet, correct? So what it does, it transmits in the form of light rather than the electricity. But at the end, when it will reach, the light will be transmitted again into the electricity only, correct? Note down certain more points: bandwidth and throughput. So what is bandwidth? Maximum speed of the connectivity, and throughput is the actual speed. This is what submarine cable map, how the fiber optic cable has been connected, right? So even this side, you can find all the details about where the locations, and even you can search based on this. So if you will find here, we have one connectivity, so it can show you all the details. Oh, it's too complex. So if you will search, let's say you are searching this one. See what it says. What is the name of this? Polar Express. Everything it will tell you who are the owners for this, everything. What is the range? 12,650 kilometers. Who is the owner? Russian government. Like this, same. Like same, you can find it for the India as well. This is no. It's right. So landing points for this cables, flag Europe, Asia. What is the distance? 28,000 kilometer. Landing points in China, and in India it is at Mumbai. Even it will show you who are the suppliers of everything for the certain particular, and it is highlighting also what it is connecting. All this. Just 1 minute. Clear it is. This is how you can search this submarine cable map. You can go through it. You can search what are the cables we have, who are the owners, everything, right? Clear? Any questions, any doubt till here? Huh? So today, what are the things we have discussed? TCP and UDP differences, headers, then handshake process, three-way and four-way handshake, flags, and cables. Tomorrow we'll start with the ROM, like types of memory, ROM, NVRAM, flash, then NVRAM, ROMON, all these things. Then we'll study, when we will discuss about that routers mode, switches mode, like enable mode, config mode, user mode. Then we'll start with the R, address resolution protocol, and we'll understand what is default gateway, what is ping, what is track proxy R, what is gracious R, everything, right? So we'll stop the recording.